Good day to all of you. So in today's lecture, what we are going to do, actually we are going to learn about the seismic data acquisition. So unfortunately we cannot go into the field. So what we have until now achieved, we have learned about the processing and also the acquisition of the data. But this is this will be a very helpful lecture for you and the hands-on as well, so which will give you an experience of doing the seismic data acquisition. So over here we have looked at all the methods like we are doing in land acquisition, sometime marine acquisition, and sometime airborne survey, and sometime we have the transition zone. So like we have the land and sometimes we have the marine together. So in that case this is quite complicated, but we will look at one of the software which is called the Tesseral Pro. So that software is quite user friendly. So once you installed it in your system, so you just no need to give any key for the time being. We are just using the trial version which can tell you about the wave propagation and how does it behave in the subsurface. So once you close that bar, so you will be having another window which shows you about the software. This is actually Tesseral Technology Incorporation, and you can visit their website as well. And I have added the exe file of the software into the healer, so you can download from there as well. And also I will provide the link into the description box as well. The first of all, let me explain about this software. So this software is quite user friendly. So this is actually the interface. So over here we can do the synthetic seismogram creation. So for that, the first step is creating velocity model, second is acquisition geometry, and the third one is the modeling. So what is mean by velocity model? Obviously, if we are going into the field, so in the subsurface we already have the different velocity of the layers or the subsurface material. But for synthetic models or for synthetic data, we must have to provide some condition. Okay, let's say in subsurface we have fault, we have multiple layers with different velocity and different density. So that is actually called the velocity model. So also some velocity model is achieved by doing the processing, NMO correction and velocity analysis. So that velocity model can also be one of the input over here. But let's say if you don't have any velocity model and you are just learning about this software or the acquisition, then you can directly create the velocity model. So let's start with the creating velocity model. So once you click here, so it will ask you about the creation of new model. So either you want to have a simple model, or if you want to have a seismic file like segway or some other files like maps file, well, or less, or SPS, and also you can take it from picture as well. So for time being we will go for a simple model. So it is asking about the model width and length, I mean the depth and the distance. So the length mean you have this offset. So let's say I put 1500, and the depth I want to assign from 0 to, let's say, 2000. And let me make it, yeah, it's okay, we just trying. So we are looking at the subsurface things. So then we press the next button. So it is asking what compressional velocity do you want to allocate for this model. So let's say standard we put 1500 meters per second, and if you want to have a vertical linear velocity gradient, then you can have that one as well, but we are going just for compressional velocity. So once you press the finish button, it will be asking about, do you want to run the acquisition geometry? Actually we want to run the acquisition geometry, but prior to that we have to define some other parameter as well. So we will hit no of this one. We want to modify our model. So as I mentioned, so we have allocated the velocity 1500 meters per second, and if you look at here, this legend supposedly should tell you about the velocity values, but right now it's not. So you can create the polygon. So in right click and create polygon. So here are some different options for creating of polygons. So either you want to have the top width, bottom width, or top separate, top bottom separate, and closed loop, and these are some options. So you can see here also the top and bottom, it will be like a polygon, but if you go for top only, so it will create only the top layer. So for here, for our purpose, we will just go for the top, click OK. So now you can start creating the layers. So let's say I start from 600 meter. So I create a very horizontal layer. You just click and double click on here. So it will be asking about the polygon number 1 and the compressional velocity. We have to change it because the background velocity is also 1500. So we have to change the 2000. And also here you can give the density value if you want. Otherwise it will take automatically. So you can just stick on that. And shear wave velocity also you can provide. So you can give the shear wave. If you're looking at anisotropic parameters, then you can give the anisotropic velocity. And here is an option, so you can make your border smooth if you want. But for this case, we don't want to have the smooth border. So you can say OK. So now you see one layer is created. So this is different velocity, and this one is a different velocity. So you can see legend 1500 meter, and now this is 2000 meter per second. Similarly, we will go and create another polygon. We'll choose the top again. So another, what we are going to do, we are going to choose a fault. So let's say I put the velocity 2500 meter per second. Okay, so now we have two layers. So if you want to edit this polygon, you can do it like this one. If you want to, maybe this is not horizontal, so you have to make it horizontal for simplicity. Okay, so if you want any more layers, like you want to have another polygon, so you can also create another polygon. And here what you can say, so now this is a bit anticlinar things I have created, so you can make it smooth. So it will make it smooth. So you see your anticline surface will become smooth. So now here you have 1, 2, 3 and 4 layer model. So now your velocity model is generated. So the second task is you have to make acquisition geometry. So in acquisition geometry, you have to click over here, acquisition geometry. So it will ask you, do you want to run the acquisition geometry? You can press yes. And now here you can see there are different type of acquisition. So like move receiver with source, zero offset shooting, fix receiver position, and source will be moving. Either you want to have the VSP, which is in case of well log or something, well data or something, and dipole VSP as well. But for the sake of understanding the acquisition geometry, so we'll go with the first option, which is move receiver with source. So you can press next. Then here is a source column. So you have to define how many number of source you want to place in this area. So let's say this is 1500 meter area. So if you want to have a source like 100 meter, then in this way you will have the 15 sources in this area. So here obviously the numbers will be automatically selected, so you have to define the steps. Steps mean the distance, how much you want to give the distance between this survey. Okay, so here you have to give the steps. Let's say 100 meter you want to have, and your shot should be starting from 0 and go up to 1400 meter, because the first shot will be at 0, the last one will be at 1400 meter. So this is about the source geometry. Then next you will having the receiver geometry. So in receiver geometry also you have to define the sampling interval. So let's say I put 25, so in 20 maybe we can put 10 meter interval, and it should be starting from 0 to 1500 meter. So it means receiver will be from 0 to 1500 meter. I'm giving the full spread, so we have the maximum data we can acquire. But we can have a less number of geophone as well. Like here we have the number of geophone is 151. But if you want to have, let's say you want to have a shot here, then your receiver should be up to 500. Then you can define the different number of geophone. So let's say if I say 500, then it will change the number of geophones. So we need 51 geophone for here. So let's go with this geometry because it will take more time for that case. So with that you can finish. So now you can see when your source, this source is active, then this will be number of geophones will be active. Then if you move to the second source, this is your second source, then third source, fourth. So your geophone are moving, I mean receivers, like here. So this will be in that case. So again you can recheck. Yes, I think the number of sources become down. Okay, 1 to 400, then 51 from 0 to 500. So I'm creating again another model and doing the acquisition parameters again. Just I do it fastly. So we decided it to be from 1400 source, then your receiver should be 10 meter from 0 to 500. So it means we have the 51. So we will hit the finish button. So now we have all the acquisition parameter geometry here. So then we can start run modeling. So before that we have to save it. So I will just save it with the existing file. So then you have the now you have to choose the modeling procedure, which procedure you want to go through. So we have the 2D acoustic modeling. Because this is a demo version, so we have only these modeling methods. So how many sources you want to have? So let's say here we have from 1 to 15 sources, and the shot gather record, so we can just hit this auto, so you can do like this one as well. Then go next. So here you can define the frequency, how much frequency you want to have. So if you change the frequency of the wave, then you will have, so this is like a vibro size, so how many frequencies you want to have. So let's say if you want to target only the shallow surface, then you can go for high frequency, otherwise you can go for low frequency as well. So you can hit next button. Then over here it's giving actually the attenuation quality. We can say okay, if attenuation will give you an accurate acquisition geometry. So with that all, just keep it default, and if you want to generate the snapshot of each sampling interval, then you can just click it, otherwise you can off it as well. And also you can use GPU if you have access to your GPU. So with that you can press finish button and it will give you a summary of acquisition parameter. So modeling method, we are doing 2D acoustic modeling. 15 shot point, and then we have the gathers, and the wavelet we have used 50 Hertz recur, and the snapshot will take years. Enable GPU, we don't have GPU at this time. So then we can start run modeling. So it will take a bit time and it will do all this 15.1 to 15 modeling. So let's take some time and you can observe this is the behavior, how the wave is going, and on the left side is the recorded section. So you can see this is your first break, then you have the first layer, then second, and most probably you will have the anticline of this one. So I will explain further once it is finished. Then we can see the wave propagation, how does it propagate into the subsurface, and what are the processes are happening behind this wave propagation. So this is the last short point, which is 15 of 15. So you can see it will show the overall 100% completed. So once the calculation is finished, I mean the wave propagation, so you will see the data set which is recorded here appears to be like this one. So over here you can see either you want to have the traces, or your traces might be filled, or whatever if you want to have this one, the background is okay, otherwise no. So we just prefer it to be like this one, which is default. So the purpose of showing this figure is now we'll look at again the wave snapshot. So over here we can do the analysis more deeply of the wave, how it reflects from these reflectors, and what is the behavior of this wave with the anticline. So this is actually your shot number one, and we have number of receiver. So if I move the time from here to here, so you can see how the wave propagate and how the data is recording in the shot record. So now when the wave propagate, so you can see it's at this point. So this means it's the direct wave. So you see this wave is recording here, so this is the direct wave. Then once the reflection it hit to this reflector, because this is the indication of our reflector, like this is straight reflector and this is fault and this is anticline. So once the wave reaches to this point at 0.45 seconds, so you can see there will be a reflection. So not only the reflection, but there will be another process which called the transmission. So reflection and transmissions appear. So this one is reflection, this is your transmission. So on the recorded data, you can't see still any event, only the direct waves are recorded here. So once this reflection will reach to the point of the reflector or to the surface, so you can see once it is reaches, still not reach, and you can see there is no data recorded. So once it reaches to the first geophone, you can see the first geophone has recorded some traces, and once it reach all the traces to here, similar way over here, if you look at once it reach to the second reflectors, so there will be reflection again. So you see this is reflection, this is transmission, and similar way, so there will be nothing recorded until this wave reaches to this point. So now the first reflector is recorded, and this is the second one will be recorded here, and similar way from this third reflector, this wave will reflect back and it will become more worse, so because of this anticline. So this is the third one. Now it is going to reach to the surface. So now it is finished here and reach to the geophone. So now on the right side is a recorded data, so you can see how does it looks like in this section. So this is called our short gather data. And how does it look in our short record? It appears to be like this. So on this data we have to do a lot of processing, such as NMO correction, velocity analysis, and everything. Then we can come up with this reflector. So this is in depth. 600 is a depth, but if you look at the time, it is 800 meter. And similar way, it is like let's say this is 1800 meter, and over here you can see it is 22, or at least 2000 meter, 2000 or 2 second you can call it. So let's do another analysis when we reach to the middle. So let's say this one. Okay. And we go here. So in this way you can see how the wave is propagating. Because our shot is here, receivers are on this direction. So it is going in this direction. So until we don't have anything, so these are all direct waves we are recorded at the surface. When it hit to this reflector, and the reflection of first reflector is receiving to this point. So this one is this one, and this one is this one. So you can see this is actually your timeline when it is reaching to others. So now if you put auto, so you can see how beautifully it is showing that this one is received here, and the third one, which is reflecting from this anticline, so it is receiving here. And over here obviously it is a bit low, but we still can increase the frequency of this data to have the better imaging. Okay, so I think you have the idea how the wave propagate and what actually mean of this short gather. So it's mean one short gather have many information of the subsurface, but the proper image will be coming after the proper imaging. Okay, so there are different short gather, but it's similar way. But the purpose of this lecture was to just explain how the wave propagate and what are the reflection and how the short gather looks like. I hope you have learned something from this lecture, and try to do the practice, hands-on practice on the different models. Obviously we have different models, and it's on you if you want to have if you want to have a polygon, like you have some normally in subsurface, then also you can do that one. Okay, I think that's all for today, and thank you so much and have a good day.